Here we have coal processing, the third part, the last part of coal processing. And in this part then we look at the last conversion of coal into other products, namely gasification. So remember now the three conversions of coal into products. We had combustion, which is providing energy, that's the main purpose there, and destructive distillation, where the coal is burnt in the absence of air, and we have the products coke, coal tar, and gases like ammonia, and then in this one the gasification. Now gasification, the purpose of gasification is to produce products, other hydrocarbon products, where the coal is now burnt in, with air, oxygen, steam, carbon dioxide, hydrogen, or a mixture of this. And from this reaction, we have then things like petrol and diesel and other industrial chemicals. Methods of gasification is indicated here: fixed bed, fluidized bed, and entrained flow bed that can be used. In the synthol process, we have the gasification of the coal, where it is changed first to synthesis gas. Now you know synthesis gas, mixture of carbon monoxide and hydrogen gas, and this synthesis gas is then introduced into the reactor, into the synthol reactor, and it's converted into hydrocarbons. The synthol and advanced synthol processes produce the light olefins oxygenates petrol, and the arch and Sassel slurry bed processes give the more dense, heavier waxes and paraffins. The products from conversion of coal into hydrocarbons are primarily refined into motor fuels, as we mentioned before. Now let's have a look at the other products that's also some of them very high value products for Sassel, that's also produced in the synthol reactor. The products coming from here. There you have your 10 major products from the Fischer-Tropsch process. Gases, waxes, syngas that is producing urea and ammonia, ethylene for plastics, propylene for also the same, higher olefins, oxygenates, aromatics, paraffins, and gasification products like tars, creosote, coke. The production of the synthesis gas, there's different gasification processes. The one that is mentioned here is the Lergy process. The coal is first gasified with steam and oxygen. The oxygen used in the gasification come from the liquefaction and distillation. You know that fractional distillation of air that we discussed. Steam come from the heating of the burning of the pulverized coal. Then the gas cleanup need to be done. Tar, oil, pitch are recovered from the fraction of the gas, and the pitch is sent to the anode coking plant, where it is also changed into coke that can be used as reducing agents further again. Other chemical products is nitrogen compounds, sulfur, phenols, ammonia, etc. There you just have an indication of the Lergy gasification. The coal is entering, steam and oxygen is introduced into the chamber, and eventually you have your crude gas, the liquor that is formed as your product. Also remember what we had before, the rectisol process that is used to remove sulfur and carbon dioxide from the raw gases so that they can be used without giving any air pollution. then it produces rather pure hydrogen gas that can be used for manufacturing procedures. The clean synthesis gas go either to the Sasol advanced synthol reactor, the high temperature Fischer-Tropsch, or the low temperature Fischer-Tropsch, where they are changed into petroleum products. The high temperature Fischer-Tropsch conversion the total feed to the reactor is made up of fresh feed, in other words, fresh syngas, synthesis gas, together with recycled gas in a ratio of 1 to 2. The higher the hydrogen gas content, of course, the easier the gasification is going to take place, which we do not really always have available, so we make use more of the lower quality coals that's not really that rich in hydrogen. Now that's why in South Africa we find that the catalyst used in the Fischer-Tropsch reaction is iron. Here we just have the discussion that's taking place inside our Fischer-Tropsch reaction, which you can read through. You have the slides available to you, but you really need not to go and memorize it. That will not make sense. But as a chemist, you must be able to tell me what is meant by syngas. Now, what does it consist of? The heating. Why is that necessary? Because heating, we know, is going to increase your reaction rate. You are going to have a faster reaction. This BFW, of course, is the boiler feed water, where the water enters, heated into steam, that is taken further. Now, inside here, you have your synthol reactor, that is then changing the syngas into your hydrocarbon products, and as it is cooled, these can be collected and separated further again. Just a flow sheet showing you the whole process. There's your Sasol synthol reactor, advanced synthol reactor. The steam and the gas that is entering. You can just have a look at it. Now the Fischer-Tropsch reaction takes place in the catalyst bed, where the gas comes in contact with the catalyst. And the catalyst, a lot of research is still done on the catalyst to make sure that we have the best possible catalyst. Now for a lower quality coal, as I already said, iron is the best catalyst. It gives you the best reaction in the end. Cobalt works very well if the natural gas is used as the fuel, because then you have a very high hydrogen content in your syngas. Then that is going to give you the best results. But with the lower quality, it's better to make use of iron. Nickel is unfortunately producing more methane. Then you don't have your longer chain carbons, and you do not really have your the fuel as we want to have from it. The iron catalyst has got a problem because it bonds too tightly to the carbon, the syngas, the carbon monoxide, and the products that are formed. So the renewal of the catalyst is quite important. The reactivity, how well it is functioning, depends on the activity level of the catalyst itself. And unfortunately, because of this carbide formation taking place on the iron surface, the catalyst get deactivated, and that need to be checked all the time. Fresh catalyst must be added, and this should be done while the reactor is still online, because they don't want to have a too long shutdown and no product is produced in that state. In that while. Used or spent catalyst is also withdrawn online, and the reduced catalyst, fresh reduced catalyst, is added. This reduced catalyst, of course, is catalyst that is treated with lots of hydrogen gas. And then it's reduced because of the hydrogen gas on it, which can then react very well in the synthol reactor. The Fischer-Tropsch reaction also produces carbon and heavy hydrocarbon or waxes as byproducts. The catalyst breaks up with time, causing an accumulation of fine materials, which causes a decrease in bulk density, so you don't have as good a reaction, as effective reaction anymore. It will be good to have a look and see if you can find more information about the catalytic reaction taking place in Fischer-Tropsch. As a chemist, that will be even a more important thing to concentrate on. Synthesis gas reacts at a lower temperature in the slurry bed reactor, produces waxes and candle wax and high quality diesel. The rest of the off gas that is sold is pipeline gas and ammonia we already mentioned.